Hi folks, we're going to do some more chapter 17 problems, and we are going to do, and I messed up the numbers, we're going to do numbers 28 through 31. So this is 28 we are starting with. What is the sound level in decibels of a sound whose intensity is 4 times 10 to the negative 6th watts per square meter? So here's our decibel equation. Decibels is 10 times the log 2 base 10 of the intensity of a sound divided by I.O., the threshold of hearing. So I want to know how many decibels, this is my question mark, 10 times the log of a sound which has an intensity of 4 times 10 to the negative 6th watts per meter squared. Now, I.O. is a constant, that's that threshold of hearing, 1 times 10 to the negative 12 watts per meters squared. So these units will cancel. So the first thing you do to solve this problem is you divide. You take these two numbers here and you divide those out. So if I take 4 to the negative 6th divided by 1 to the negative 12th, I get something like 4 million, something like that, and I'm going to take the log of that number. And when I get the log of that number, and make sure when you're putting this in your calculator, you're going to use log, the LOG button. Do not use the natural log button. That is base E, Euler's number, and you don't want that. You want LOG log, because that's going to be base 10. When I do that, I end up with 6.602. Now, I still have to multiply that times 10, and that 10 takes it from being in bells to being in decibels. So multiply that by 10, and I end up with an answer of 66.0 decibels. Now you might wonder, where do the units decibels come from? Because these units just cancel out. That's just the unit that is put on sound level, and they kind of are magically appear when you do this equation. So that is how you find those. Next, what is the sound level of a sound wave with an intensity of 9.63 times 10 to the negative 3rd watts per meter squared? So sound level, if it ever says sound level, you're looking for decibels. That's what your unknown is. So that's going to be 10 times the log, the intensity of 9.63 times 10 to the negative 3rd watts per meter squared, divided by the threshold of hearing, 1 times 10 to the negative 12 watts per meters squared. So first thing you do, divide. So I'm going to take this one at a time. Okay, so 9.63 times 10 to the negative 3rd divided by 2 to the negative 3rd divided by 1 to the negative 12th. When I do that, I get a big number, and I'm going to do the log of that number, and I end up with, when I do the log, I end up with 9.98, and that's my bells. Multiplied by 10 gives me decibels, and I end up with decibels of 99.8 dB. All right, so same thing. These are not hard problems. You just have to spend some time messing around with your log button on your calculator. All right, the next one is going to be number 30. Number 30 says this: the bellow of a territorial bull hippopotamus has a measured sound level of 115 decibels. What is the sound intensity? So this one we're going in a different direction. This time we know decibels, and we're looking for I, intensity. That's my question mark. So I've got 115 decibels is going to be equal to 10 times the log. I'm looking for I, and the threshold of hearing, I.O., is that constant. So this is going to be 115 dB is 10 times the log of I. I/O, of course, is 1 times 10 to the negative 12th watts per meters squared. That's that constant. Now, what do you do to solve for this problem? First thing you're going to do to make it simpler is you're going to divide both sides by 10. All right, divide both sides by 10 just to simplify the whole thing. So that's going to get that. 115 divided by 10, you're going to end up with 11.5. The decibels at this point is going to evaporate, and you're going to end up with the log of I divided by 1 times 10 to the negative 12th. Now, how do you undo a base 10 log? To undo a base 10 log, you're going to raise each side to the power of 10. Okay, raise each side to the power of 10, and that is how you undo a regular log. So what does that look like? We're going to end up with 10 raised to the 11.5 power is going to equal I divided by 1 times 10 to the negative 12th. Now, how the heck do you do this on your calculator? A couple different ways you can do this. On your calculator, you can do this. I'm going to write off to the side. On your calculator, you can do this. You might have a 10 to the x button. Some people have a y to the x button where you can put 10 and then you can go hit this button and then you go shoop 11.5. Some calculators have a little up arrow button, so you can hit 10 and then the up arrow button 11.5. There's a couple different ways you can do it, but you know you're going to do it right if you get this. So I'm going to go 10. Where's my 10 to the button? I'm looking on my calculator. There is my calculator. So I'm going to go to my 10 to the button, 11.5, and I'm going to get, when I do this, that translates into 3.16 equals I divided by 1 times 10 to the negative 12th. At this point, it's just algebra. So now I'm going to multiply both sides by 1 times 10 to the negative 12th to the negative 12, and I get an intensity of 0.316. And the units do come with this number, so this is watts per meter squared, and that is going to be the intensity. And I'm just going to double check, make sure I didn't do anything silly. Woohoo! That's the same answer I got when I did the problem before, so life is good. Okay, let's do one more of these. What is the sound intensity of a 68 decibel sound? All right, one more time, we're looking for sound intensity, we're looking for I. So I've got 68 dB equals 10 times the log of I divided by 1 times 10 to the negative 12th watts per meter squared. What are you going to do first? Yep, divide both sides by 10. So 6.8 equals the log of I divided by 1 times 10 to the negative 12th watts per meter squared. How do you undo a base 10 log? Raise it to the power of 10. So 10 to the 6.8 power is going to be I divided by 1 times 10 to the negative 12th. And when I do this, so 10 raised to the 6.8 power, I get a big honkin' number times 1 to the negative 12th. I'm going to end up with 6.31 times 10 to the negative 6th watts per meter squared. All right, best of luck with these, and we'll see you later. Bye-bye.